We're getting a late start here today on Friday afternoon, but hopefully we can get some of these done and I can get home. So let's go ahead and get started here. We're looking at AP Calculus AB sample test number 4, and this is the non-calculator portion. We're just going to start with numbers 1 through 9. I'm going to try and split the videos up into smaller pieces again. That seemed to load a little bit better for a lot of you guys. So here we go. Number 1. They love to start off with an easy problem. It is an easy problem. Don't overthink it too much. But let's go ahead and see what we got. First, anytime you have a limit, you always got to evaluate at the given point. So what we want to do is go ahead and plug in what we have and see what happens. If we do the limit as x approaches b, as x approaches b, that means wherever there's an x, we're going to put a b in there. That means in the bottom here we'd have square root of b minus square root of b. And you look at that and we get 0 over 0, and that doesn't make sense mathematically, except to know that something's going to reduce in here, because this is really going to be a hole in our function. So let's see what we can do to reduce it. Well, you guys probably have some instinct telling you something about you have like a squared minus b squared over a minus b. We've seen stuff like this. We've even seen a squared minus b squared over b minus a, where this top is going to be a plus b and then a minus b, and then on the bottom we have b minus a, but we're going to take out a negative, and then we'll have then we'll have an a minus b down here. You can always swap the order of a difference, in this case b and a, if you take out that negative. And then we could reduce with this top factor, leaving just a negative 1 on bottom and a plus b on top. So we have all this going on in the same problem. Even if you don't see it, it is there. It is just a difference of squares. What you need to look for is, if this is a and b, if this is a, then that would be a squared, or if this was a, that would be a squared. So let's rewrite what we have. We have the limit as x approaches b. We have b minus x, but I'm going to take out a negative, so I'll put a negative 1 here. And then it'll be x minus b. And on the bottom, we have x to the 1/2 and b to the 1/2. So those are the values that we have. Now here's where it's kind of cool. If I look at this, x to the 1/2, if I square that, or the square root of x squared, is just going to be x. So it's the same thing as what's happening here. I have something, square root on the bottom, or something down here on the bottom, and then when I square it, I get the top term. So another way of thinking of that, if we have square root of x and then we square it, that's going to equal x. So it still fits the same pattern. So using that idea, I can rewrite this as limit as x approaches b, and I still have this negative 1. I can factor the top and I can factor the bottom. Well, I can't factor the bottom, I guess, but we've got square root of x minus square root of b. It doesn't really matter how I write it. But up top here I'll have square root of x plus square root of b and square root of x minus square root of b. That square root of x minus square root of b is going to reduce on top and bottom. It's just 1 over 1. So now I can plug in b. So it's going to equal negative 1 times square root of b plus square root of b, which is really negative 1 times 2 square root b, which equals negative 2 root b. Bam! Number 1 equals a. 8 more and we're done with this video. The equation of the tangent line. Hit the brakes. Y minus y1 equals m times x minus x1. Whenever we're looking at a tangent line, it's always good to be thinking of this. Why? It just keeps it simple. We don't overthink it. Okay, so we got this graph. Y equals cosine of x tangent to x at the point 0, 1. Bam! They already gave me x and y. That was a bam. Alright, so that means y minus 1 equals something times x minus 0. So even if I was silly and I had no idea what was going on, I could actually solve this pretty fast. Because if you look at this, this is going to be y minus 1 equals my slope, m times just x. And then when I add 1 to the other side, it's going to be y equals mx plus 1. So D's out, C's out, A's out. It's only B or E. Just by knowing algebra, I automatically restricted it down to 2 possibilities. So let's see if we could figure out what m is. It's either 1 or 2. We know that. In order to figure out the slope of a function, we need the derivative. So y prime equals, take the derivative of these pieces. We can do each one separate because we're adding them. Cosine of x is going to become negative sine of x. Tangent 2x, well, the derivative of tangent of u is equal to secant squared u times du. So it's going to be plus 2 secant squared u, because du is 2. So y prime then equals negative sine of, we got to plug something in, plus 2 times secant of whatever that thing is. And that x value that we plug in is 0. 0. Negative sine of 0 is 0 plus 2 times secant of 0. Secant of 0 is 1, which equals 2. So E is out, and 2 is our slope. So B is our answer. Number 3. The graph of the function f, whose domain is the closed interval, 1, 7, is shown above. It's actually shown down here. Which of the following statements about f of x is true? The limit as x approaches 3 of f of x equals 1. So as I'm going to 3, the limit is 1. It's f of 3 equals 1. But wait a second. The limit as x approaches 3, as it's getting close to 3, if I were to cover up that little dot like this, what does it look like it's going to become? It looks like it's going to become that other piece up there. Let's erase that, bring it back. The limit is not equal 1, it equals 3. The limit is where it's going, not where it is, but where it's going. The limit as x approaches 4, so where are we going as we go to f of x? Well, it looks like we're going to 1.5 on this side and 3 on the other side. That doesn't work because the left does not equal the right. So neither one of these, A or B, are true. F of x is continuous at x equals 3. No, to be continuous, the left has to equal the right, which also has to equal the middle. The limit coming from one side has to be the same as the limit coming from the other side, and you have to meet in the middle. Got to fill the hole. F of x continuous at x equals 5. True, ding, 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 because it's coming from the left. It goes to 5, or it goes to something at 5. It's coming from the right, and it goes to something. And it actually hits that point that it looks like it's going toward. D is true. But just to make sure, limit as x approaches 6 is not 6, because f of 6 is down here. And this is the limit as x approaches 6 from the left. And this is the limit as x approaches 6 from the right. So there is no limit as x approaches 6. So it is D, just to be sure. Number 4. Ooh, look at this. Look what they're trying to do. They're saying take the derivative, but then they sneak it in here and tell you, oh, you're taking absolute value. Just anytime you're doing absolute value, guys, it's always good to kind of visually understand what's going on. So let's go ahead and give ourselves a couple of x and y axes here. And now let's see how awesome we are at remembering what this does as far as transformations. First of all, I see a -2 on the inside. So that means I'm going to move, what would that say, move to the right 2. And then it says +3 on the outside. That means it's going to move up 3. So normally on a graph of absolute value, I start here. So I'll do that in gray. So your typical absolute value graph would look like this, like this. That'll be kind of our ghost. And then what we want to do is we want to move it. We're going to move it right 2 and up 3. So we're going to go right 2, 1, 2, and up 1, 2, 3. So we're going to be here now. Let's start with black. So this is our new function. And it's saying f prime of 2, f prime of 2. Whoa, that's kind of interesting because we are right here, right at the sharp corner point. And there's only a few things that make derivatives not exist. First, if the limit does not exist, well, the limit does exist because the right and the left and the middle are all converging at the same point. So the limit does exist, but that's not an issue for us. But we have a sharp corner. And what that is basically asking is the slope from the left equal to the slope from the right. Another way to think of that is it smooth? The answer is no, so it's non-existent. Next. Hey, that's pretty awesome. This is an easy one. Okay, first of all, I'm going to do it wrong. I want you guys to see if you watch and can see how I'm doing it wrong. So when I take the integral of 3x plus 5 squared dx, red is wrong. Don't copy this down. This is wrong. Red is wrong. Okay, so if I were to see this power and say, oh, that must be a little power rule, so I'm going to do 3x plus 5, and I'm going to raise this to a third power and then divide by 3, and then add c. A lot of people do that. That's wrong. That's not wrong, or that's not right. That's wrong. And some people say, oh, so I take the derivative, but then I subtract 1 and then go from there. No, that's wrong too. And then they might say, oh, no, it was a chain rule where you have the 3 up here and the 3x plus 5, and then when you take the derivative, that becomes 3 times 3x plus 5. And then, oh, I'm so smart because I remembered to multiply by this 3 here, or add that 3. And that's somehow coming up with these pieces. No, those are wrong. So what do I really need to do? What I need to do let's do something in green. How about that? That's a color we haven't used in a while. Let's take care of this one. Change it to green. Okay, so green is good. Good. First thing I would like to do is I notice that I can do some algebra first. So I'm going to do algebra first. And the algebra that I'm going to do, I'm just going to simplify this a little bit. So 3x plus 5 squared is really 3x plus 5 times 3x plus 5. And then if I were to multiply that out, I get 9x squared plus 30x plus 25. Now I take the antiderivative. So I'm looking at this and I'm asking myself, what would the antiderivative of this be? Well, if I pull the 2 down, that's going to become, or actually this one's going to become 9x cubed over 3 plus 30x squared over 2 plus 25x plus c. That's what I would get. Now if I were to simplify this a little bit, I would get 3x cubed plus, what do we got here? 15x squared plus 25x plus c. And as I look at this is kind of interesting because none of these are a correct answer. So I'm guessing that the test actually has some things wrong. Maybe they, I don't know. I don't know what they did. The only possible answers that I'm looking at would be D or A. And I don't think it's A. Must be D in here. There's one other possible way to derive this. I'm going to see if we can work with that. So, I could actually do a U substitution, I think. So if I did a U substitution, that would mean that U equals 3x plus 5, du equals 3dx, and I have 3x plus 5 squared, and I need a 3, so I gotta multiply by another 3 on the outside, and we got the dx. Now this would be u squared du times a third. Okay, so the antiderivative of u squared is going to be u cubed over 3. So that's what they did, plus c. I'm getting it. I followed. Okay, that means that we're going to have 1/3 times u cubed, which is 3x plus 5 cubed over 3, so we get the 1/9. The answer is even. Oops, wrong one, D. Tricked ya. It's D. Must have done something wrong here. Trying to see what we have. I'm not sure. Oh, that is tricky. I see what's happening. Yeah, they kind of added and subtracted a constant in here so that this would factor out to this. That is pretty interesting, pretty tricky. So the proper way that they would have found it was U substitution, which would have gotten us the answer D. All right, number 6. The position of a particle on the x-axis at time t greater than 0, greater than 0. Why do we even have to say that? Because we're doing natural log, and you can't do natural log of 0. Whoops, I can't do that. The average velocity. I'm given position. I'm asking about average velocity. How are position and velocity related? How is position and velocity related? I need to understand that in order to understand this question. Position, the derivative of position, or d dt in this case, is equal to velocity. So the slope of position is equal to velocity. So the average slope of position is equal to the average velocity. So the average rate of change of position is equal to the average velocity, which is really just y2 minus y1 over x2 minus x1. So if I look at that from 1 to e, this is my x1, x2, or t1, t2, I guess you could say, t1, t2. That means that I'm going to have a fraction on bottom is going to be e minus 1, and on top is going to be natural log of e minus natural log of 1. Now if I were to simplify that, natural log of e is 1, natural log of 1 is 0, then e minus 1 on the bottom. The answer is B. That's a very easy calculation if you understand this. That's important to understand relationships between velocity and position. And when it's asking for average, whenever you're trying to be asking about the average value of the function that you have, not its derivative, not its antiderivative, but of its actual function, so the average value of the given function. So if they asked us average position, that's the whole 1 over b minus a from a to b of the function. But if it's asking the average value of the derivative of the function, that's just slope. This is huge, huge, so big we're going to do a big orange box around it. Then we're going to make that box bigger. Oh, it looks like it grouped everything. That's okay. Big orange box. Next. If e to the xy equals 2, then at the point 1, natural log of 2 dy dx equals. We got x's and y's mixed. So we have to do implicit differentiation. So we have e to the xy equals 2. Now you don't have to do this, but this is probably what I would do, just to make it easier on myself. I look at this and I see natural log, natural log. Oh, that's so much easier. X, y equals natural log of 2. Why is this easier? Because when I take the derivative of this one, this part's going to go to 0. The derivative of a constant is just 0. So let's do that. Wow, that was so much easier than the way they probably expected me to do it. Well, maybe they're expecting me to do this. xy equals natural log of 2. So now I got a product rule. X prime y plus y prime x. So I'm going to have 1 times y plus 1 times x, but one of these gets a dy dx. Which one is it? It's the one that had me take a derivative of y. Well, that's a derivative of y, so I need this to be dy dx. That means that dy dx times x plus y equals 0. So in other words, dy dx times x equals negative y. And we divide by x on both sides. So dy dx equals negative y over x, which in this case is negative natural log of 2 over 1, which equals negative natural log of 2. It is that easy. Booyah. If f of x equals this piece, then f prime of x. Oh my gosh, so easy, so easy. I can't believe they're giving us all these easy ones so early in the test. We would get an A on this test if we knew we could. Alright, f prime of x is just a derivative. I have a product rule. That product rule is going to have 3x and natural log of x. Remember, if this is our u and our v, then really we need u prime v plus v prime u. Okay, that's easy enough. Let me see if I can move this piece out of the way. Alright. We'll do this one in blue and the other one in red. So the 3x, u prime is 3, and u is going to be 3x. And then we're going to add in the middle. And it's going to be 3 times v. So that's natural log of x. And then over here, v prime, the derivative of natural log of x is 1 over x. Let's see how that simplifies. This would become 3 natural log of x, and then 1 over x times 3x is just 3. So it's 3 natural log of x plus 3. Wow, that's kind of weird, because that doesn't seem to fit any of these. Wait a second. Yes, it does. Tricked ya. Why? Because whenever you have a constant in front of natural log, it's really the same thing as that constant moving up to the top. Natural log of x cubed plus 3. There we go. A would have been our answer. Number 9. Number 9, number 9, number 9. Okay, guys, this is not bad, especially if you can visualize your absolute values. So let's make a graph. Now, if I see that it's x plus 2, that means that my graph is actually going to start about, we got, let's say, 1 and 2. Then that means our graph is going to move to the left. Now, if I'm smart and I remember a little bit about absolute value, I know that it has just a constant slope on either side, depending on if there's any change. There is no change out here, so it's just constant slope of 1 on either side. And we're going all the way till 3. I believe. Yep, there we go. So we just need to find this area. That's really, really not hard at all. Now, I could do the integration, but oh my gosh, didn't you learn geometry? What's this? 1 by 1, and this is 1, 2, 3, 4, 5 by 1, 2, 3, 4. Does this go up to 5? Yes, it does. It goes up to 5. So we got 5 times 5, base times height divided by 2, plus the other base times height divided by 2. And then if we start to put that together, we got 25 halves plus 1 half equals 26 halves, which equals 13. This is geometry. That's it for that video. Join me for the next one.